Alright students, you're welcome back. This is NECO 2021 physics, the one that has been done this year 2021, and I started with the objective parts. So we solved the objective parts. I've solved the objective parts. So the theory part also has been started, has been solved. The part 1 of the part A of the objective part, which is 1 to 11, that one has been solved, and I've uploaded the videos. Then so you can click on the subscribe button in order to see the videos. So this is part 2 of the theory part. So this is part 2 of the theory part. So 1 to 11 have been solved, as I've said before. It has been uploaded. So we are continuing from number 12, which is the second phase of the objective part. Please click on the subscribe button to see the other videos I've uploaded in physics, chemistry, maths, and all that. So don't forget to click on the like button and the subscribe button. So this is Campus Academy, where we simplify everything. All right, number 12A, starting from number 12A now. So number 12A, don't forget, feel free to call me or WhatsApp me on 090-745-26311. 090-745-26311. So I'm equally into home tutoring for maths, further maths, physics, chemistry, and technical drawing. So you can also see that on my videos. When you click on the like and subscribe button and you go to YouTube, you search for me, you see it there. Okay, so number 12A says, 12AI says, explain fundamental quantity. Explain fundamental quantity. So say explain fundamental quantity. Fundamental quantity are the basic quantities. Fundamental quantities are the basic quantities that are not derived from any other quantity. Fundamental quantities are quantities that are basic quantities that are not derived from any other quantity. That's 12AI. Now I says, mention two quantities which have the same. When you explain that fundamental quantity, when you define it, you give examples. That 12AI. When you say, you can say explain fundamental quantity. When you define it, you give examples. Examples of fundamental quantities are length, mass, time, electric current, luminous intensity, and all that. So when you mention like 2 or 3 is okay as examples to back it up. So let's now go to 12AII. 12AII says, mention two quantities which have the same unit as energy. Don't forget that my explanation in this NECO physics will also help you in the forthcoming WAEC, also help you in WAEC, because NECO is National Examination Council. It was written before WAEC, this particular 2021 year. Okay, so mention two quantities which have the same unit as energy. That's 12AII. Mention two quantities which have the same unit as energy. Work has the same unit as what? Energy. The unit of energy is joules. The unit of energy is joules. So work, the unit of work is also what? Joules. Another one is heat, HEAT, joules also. So work and heat, so they have the same unit as what? Energy. Let's go to 12B. 12B says, sketch a velocity time graph. Sketch a velocity time graph of the motion of a pendulum bulb swinging from end to end. Sketch a velocity time graph of the motion of a pendulum bulb swinging from one end to another. Let's sketch that on the board. So sketch a velocity time graph of the motion of a pendulum bulb swinging from one end to another. So draw the vertical line, draw the horizontal line. The horizontal line is time, is seconds, because they said velocity time graph. Then the vertical line will be velocity in bracket meters per seconds. Velocity in bracket meters per seconds. Then origin is 0, 0, starting both axes from the origin. Okay, now said sketch a velocity time graph of the motion of a pendulum box swinging from one end to another. So it's going to be in this form. As many as you can. So that is it. So velocity time graph of the motion of a pendulum bob swinging from one end to another. Don't forget, for a pendulum bob swinging from one end to another, the velocity is maximum at the equilibrium position. The velocity is maximum at the equilibrium position, and it is minimum at the ends. So we are saying that it has velocity has its highest value at the equilibrium position. The equilibrium position is also called the mean position, MEAN. It's also called the center position. Are you there? So velocity has the highest value at the mean or equilibrium or center position, but it has minimum value or zero value at the ends. So it's going to be sinusoidal. So that's the graph of velocity against time. So we are done with 12B. So let's go to 12C. 12C says, 12C is a calculation question. 12C is a calculation question. The question says, a meter rule of mass 15 grams. A meter rule. Listen to the question, you can write it down. A meter rule of mass 15 grams pivoted at the 30 centimeters mark, balanced horizontally when a load of 25 grams was hung at the 18 centimeters mark. So a meter rule of mass 15 grams pivoted at the 30 centimeter mark, balanced horizontally when a load of 25 grams was hung at the 18 centimeter mark. So lest I forget, part of the videos I've uploaded in maths, I discovered a very short method to solving equation of a circle. Short method that you can only use your eye to solve it without writing anything down. Within 3-4 seconds, you get your answer. To get this, the coordinate at the center of a point in the equation of a circle. So click on that subscribe button and like, so that you can see the video. So a meter rule of mass 15 grams pivoted at the 30 centimeters mark, balanced horizontally when a load of 25 grams was hung at the 18 centimeters mark. It now says sketch the setup. Let's do that. Sketch the setup. So a meter rule. So meter rule is in this form. Okay. See, they were supposed to tell us that they were supposed to say the question was supposed to say a uniform meter rule. A uniform meter rule, so that we can say that the center of gravity is at the 50 centimeter mark. A meter rule runs from 0 to 100. 0 to 100. That's the length of a uniform meter rule. So the center of gravity will be at the center at 50 centimeter mark. Are you there? So that means you put the mass of the meter rule at the center of the meter rule. Are you there? So you put the mass of the meter rule at the center of the meter rule. They say a meter rule of mass 15 grams. The mass of the meter is 15 grams. So and the length is 100 centimeter. So the mass of the meter will be at the center. So if from here to here is 100, then center will be at 50. So let us assume this is 50.50. So at the center you put the mass. The mass is 15 grams. 15 grams. Okay, that's mass. It's a meter rule of mass 15 grams. Okay, we have put down at center. That means from here to here is 50. From here there is also what? 50. I can show that. Let's show that from this point to this point is 50 centimeter. 50 centimeter. Okay, and then from this other end to this other end is also 50 centimeter. Okay, that's 50. So 50 centimeter. That's from this end to other end is 50 centimeter. This to that. Okay. That's a meter rule of mass 15 grams pivoted. Meter rule of mass 15 grams. We have put 15 grams at the center, which is at 50 centimeter mark. Now they pivoted at the 30 centimeter mark. Pivoted, that is, a pivot was put at 30 centimeter mark. You must always read. Let me put 0 here. It's 0, 100. You must all 0 centimeter to 100 centimeter. So you must always read from 0. All your readings must always be from 0. Are you there? Now say pivoted at the 30 centimeter mark. That means a pivot is put at 30 centimeter mark. A pivot, or we call it knife edge. Are you there? So reading is 0, reading 30 cm from 0. From here to here is 50. Are you there? So 30 will be somewhere around here. Let's say somewhere around this place. So you put your pivot, a kind of the support, knife edge. Okay, so that means from this side to this side is 30. Okay, let's show that with our, from here to here is 30. Okay, that's 30 centimeter. 30 centimeter. Okay, that is that side. From here to here is 30 centimeter. And from this side, the meaning point here to this side is 20 centimeter. That's 20 centimeter. Are we together? So from here to here is 30 centimeter. And write this 3 very well. Okay, 30 centimeter. From here to here is 30 centimeter, while from here to here is 20 centimeter. Okay, all right. So pivoted, say it's pivoted at the 30 cm mark. Balance horizontally. Balance horizontally when a load, balance continuation, balance horizontally when a load of 25 grams was hung at the 18 centimeter mark. So a meter rule of mass 15 grams, we have settled that. Pivoted at the 30 centimeter mark, we have settled that. Balance horizontally when a load of 25 grams was hung at the 18 centimeter mark. I told you that all your readings must be from 0. So balance horizontally when a load of 25 grams was hung at the 18 centimeter mark. So let's count 18 from 0. You know, from this side to this end is 30. From this side to this side is 30. Are you there? So we want to deduce 18 from this plate. So 18 from 0, let's count 18. So middle of this is 15. So let's assume that somewhere around here is 18. Okay, this is where we are going to put the load, 25 grams. 25 grams. 25 grams. So that means from here to here is 18. So from this point to this point is 18 centimeter. Are we together? So if from here to here is 30, from here to here is 30, and from here to here is 18. So what is from this point to this point? From here to here is 30, from here to here is 18. So what is from here to here? That will be 30 minus 18, which is 12. That means here is 12 centimeter. So here is 12 centimeter. 12 centimeters. Okay, are we together? All right. So from here to here is 18, and from here to here is 12. And don't forget that remaining from this point to this point is this 20. From here to here is this 20. So you can bring it down if you like. Let's bring it down. That's 20 centimeter. Okay, 20 centimeter. All right. They said we should sketch it. We have sketched that. They said 12 CI. Sketch the setup. This is sketch. You found that. Then you can as well put your reaction on the pivot. You know, there will be a reaction on the pivot. So reaction, upward force on the pivot. So you can put your reaction, that there will be reaction on the pivot. That's capital R representing the reaction. Okay, reaction on the pivot. So that's a sketch. So we found out that when we look at when you take moment about the pivot, are you there? If, when you multiply 25 with 12, 25 times 12 will give you 300. Let's say 25, it must be equal. 25 times 12, the distance, or if you take a moment from the pivot, distance of the pivot to the mass 25 grams, distance of the pivot to this mass 25 grams is 12. So that's 12, which is distance times the mass 25. That's giving us 300. 300. Are you there? 300 grams centimeter. Okay. Now the other side also, distance of the pivot to the mass 15 grams. Distance of the pivot to the mass 20 grams is 20. So 20 multiplies by 15. I mean by 15. So 20 multiplied by 15. You also give it 300. So it must be equal on both sides. So that means correct. So that means that is correct. So that has been sketched. So they now said that's one figure 1. Then one figure 2, they said if the position of the pivot is moved to the 33 centimeter mark, if the position of the pivot, you do not shift the pivot, you know, from it was at 30 centimeter mark before, if you now shift it towards 15 grams to 35 centimeter, I mean to 33 centimeter mark, if the position of the pivot is moved to the 33 centimeter mark, comma, by how much must the load be reduced to maintain the horizontal balance of the roll? So if you shift the pivot from 30 to 33, the meter will not be balanced again. Are you there? The meter will not be what? Balanced again. It's either you now adjust the 25 grams mass, you now adjust it, you adjust the 25 gram mass to balance it, or you find another mass that is lower than 25 grams to balance it. But here they want us to keep the position, they want us to keep the position of the 25 grams at 18 centimeter mark, but they want us to keep the position at 18 centimeter mark. They will now find another mass. They put another mass at 18 centimeter mark, another mass that is lower than 25 grams to balance it. They say if the position of the pivot is moved to the 33 centimeters mark, by how much must the load be reduced to maintain the horizontal balance of roll? If you shift the pivot from 30 to 33 centimeter mark, the meter will not be balanced. So there are two ways of balancing the meter rule now. It's either you adjust the position of the 25 gram mass, you adjust the position, maybe shift, maybe move to the left or to the right so as to balance it horizontally. That's one way. Another way is for you to bring another mass that is lower than 25 grams, and put it at position 18. Right there, it will balance. So they want us to go with the second way, that is bringing another mass, you put it at 18 centimeter mark, and that mass you are bringing must be lower than 25 grams. So let's now see that. So we have to sketch now. Let me still maintain my meter rule. This is my meter rule. Don't forget it must be straight. That's uniform meter rule. Okay. All right. I have my 0 is from 0 to 100, or 100 or 0 to 100, or is 0. That 100 centimeter means 1000 millimeter. Are you there? Practically you see it as 1000 millimeter. Okay, 0 to 1000 millimeter. 1000 millimeter means 100 centimeters. All right. Okay. So that said, if the pivot is moved to 33 centimeter mark, I told you that all your distances must be read from 0. So it's pivot is moved to 33 centimeter mark. So from 0, let's assume the 33 centimeter mark is somewhere around here. Okay, that's it. That means from here to here is 33 centimeter mark. So if from here to here is 33, and then we know that the mass of the meter rule still remains at 50 centimeter mark. as in these 15 grams still remain at 50 centimeter mark. Let's count. Okay, from 0 to 50. Okay, let's assume the 50 is somewhere around here, center 50, that is 0.50, giving us the mass 15 grams. So don't forget that the mass of the metal, which is 15 grams, is still maintained at the center of gravity at 50 centimeter mark. So from this point to this point is 50. Then from here to here is also what? 50. From 0 to the mass 15 grams is 50. Are we together? Is 50. So if from this point to this point is 50, then from this point to the pivot is 33. So what is remaining here? Let me shift pivot small. So let me assume that this is the 33 centimeter mark of the pivot. Okay, it's just a sketch. Okay, so let me make it clear. So if from here to here is 33 centimeter mark, okay, and from this point to the 15 grams is 50 centimeter mark. From here to here, from the 0 to pivot is 33, then from 0 to 15 grams is 50. So what will be the remaining distance here? That is 50 minus 33. 50 minus 33. 50 minus 33 will give us what? 17. So that means the distance, remaining distance here is 17 centimeter. 17 centimeter is what is remaining here. Okay, and from this point to this point is 13. You found that from here, if from here to here is 13, 13 plus 17 will give us 50. That is from 0 to 15 grams is 50 centimeter. Correct, right? Now, that is that. Now, I told you that the new mass we are bringing, we must be maintained at 18 centimeter mark. Are you there? The new mass we are bringing must be maintained at 18 centimeter mark. So let's count 18 from 0 here. You know, from this side to this side is, from this 0 to pivot is 33. So let's count 18. So 18, okay, 18 is, let's say 18 is somewhere around here. 18, the position 18 is somewhere around here. So we are putting our mass, unknown mass, M. Let it be M, unknown mass M. Okay, so from 0 to this unknown mass M that we are bringing is 18 centimeter. So here is 18. All your distances must be right from 0. Here is 18. So from here to here, don't forget that from here to here, from 0 to the pivot is 33. From 0 to the pivot is 33. And you have cut off 18 from it. You have cut off 18 from it. So to know the remaining distance there, that will be 33 minus 18. 33 minus 18. So 33 minus 18 will give you what? 33 minus 18 will give you 15. Okay? 33 minus 18 will give you 15. So that means the distance here is 15. Okay, that's 15. Alright. Okay, so you can like put your reaction on the pivot. Capital letter R. Okay, that's reaction. Okay, acting vertically upward. So the M is what we are looking for, the mass, the unknown mass. Okay, that is the new mass. It said by how much must the load be reduced? Are you there? So we have to get this mass first. When we get this mass, are we there? But that we now get, we now subtract it from 25 grams, the old mass, to know how much it has been reduced. Okay, so when now see taking moment about the pivot. So let me clean the upper one. Taking moment about the pivot. Just write. Let me solve it here. Taking moment about the pivot. It means that the first mass is M. M times the distance between M and pivot. The body is with mass M, right? That is M multiplied by the distance of M to the pivot, 15. So all equals to, the second mass is 15 grams. 15 grams. That's 15. Don't forget that I said mass, the body of mass m times its distance to the pivot, 15. M times 15 equals to second body is of mass 15 grams. 15 grams, that's 15 multiplied by its distance. The distance of this mass 15 grams to the pivot is 17. That's 17. Okay, so now let's make m the subject. So m becomes 15 times 17 over 15. 15 times 17 over 15. Are we there? So 15 cancel 15. So our mass is 17 grams. Our mass is 17 grams. Okay, so the new mass we brought, or the new mass we are bringing, is 17 grams. But that's not the final answer. Are we there? So they now said, by how much must the load be reduced to maintain the horizontal balance of the roll? So you now subtract this new mass from the old mass. The new mass is 17 grams. The old mass is what? 25 grams. So 25 minus 17, that gives you 8 grams. 8 grams. 8 grams. So 25 minus 17. So the old mass is 25 grams minus the new mass 17 grams. So 25 minus 17 will give you 8 grams. So 8 grams is the final answer. So is the reduction in the mass. Say by how much must the load be reduced to maintain the horizontal balance. All right, that's that for the whole of number 12. That's that. So if this is interesting, all right, you can say, okay, let me wipe this one up. The final answer is 8 grams. Okay, let's move to number 13 now. 13a. 13a says, distinguish between elastic and inelastic collisions. Students, distinguish between elastic and inelastic collisions. So how do you answer that? So now, elastic collisions occur. Are you there? Elastic collisions occur when two bodies collided in such a way. When two bodies collided in such a way that their momentum and kinetic energy are conserved. Elastic collisions occur. Elastic collisions occur when two bodies collided in such a way that their total momentum and total energies are conserved. Total momentum and total energy are conserved. That is, their momentum before collision is equal to their momentum after collision, and also their kinetic energies before collision is equal to their kinetic energies after collision. So a good example is the molecules of a gas. The molecules of a gas are perfectly elastic. That is one of the postulates of the kinetic theory of gases. The molecules of a gas are perfectly elastic. That is, they collide with the walls of the containing vessel. They collide with the walls of the containing vessel without loss of energy and without loss of what? Momentum. That's that their momentum before they collided with the wall of the containing vessel is equal to their momentum after when they collided with the containing vessel. So that's a good example of elastic collision. Now, inelastic collisions. For inelastic collisions occur when two bodies collided in such a way that their momentum is conserved, but their energy is not conserved. Inelastic collisions occur when two bodies collided in such a way that their momentum is conserved, but their kinetic energy is not what? Conserved. It means that their kinetic energy before collision is greater than their kinetic energy after collision. That is inelastic collisions. Inelastic collisions. So we have differentiated between elastic and inelastic what? Collisions. That's number 13A. So let's go to number 13B. 13B says a calorimeter containing 65 grams of ice. A calorimeter containing 65 grams of ice at minus 10 degrees Celsius is heated uniformly until it boils after 180 seconds. A calorimeter containing 65 grams of ice at minus 10 degrees Celsius is heated uniformly until it boils after 180 seconds. Full stop. Sketch a labeled graph to illustrate the variation of temperature of the ice with time. So sketch a labeled graph to illustrate the variation of temperature of the ice with time. That means temperature is coming first, time is coming second. That means temperature will be on the vertical axis, while the time will be on the horizontal axis. So let's sketch that. So let's have this, or have something like this. Okay, our origin is 0, 0. Don't forget the corner says label diagram. So this is our temperature, capital T. Okay, you put the unit degrees Celsius in brackets. Capital T, degrees Celsius in brackets. Then the horizontal axis is time in seconds. That's time in seconds. Okay, small letter T in seconds. Okay, then you put the origin 0, 0. Okay, then you sketch. We are looking for this. Is heated until it boils after 180 seconds. Let's use 50, 100 on the time axis. Let's use 50, 100, 150, 200. Okay, let's use that scale on the S axis, on the T axis, or the time axis. Okay, now on the temperature axis, let us use 100, 200, 300. Are you there? 100, 200, 300. Yes, 100, 200, 300, like that. So we have, can we use 100 like that? We have minus 10. I will still consider minus 10. Yeah, no problem. 100, 200, 300. Or should I? If I don't, we can also use 50, 100, 150, 200. Do you understand? So it says in as much as you state your scale. Okay. So let's use 100. 100. I want to use 100 here. 100. Then followed by 200. So they will come down. Also, I have minus 100. Then minus 200. So on the we must have a negative T axis because of the minus 10 degrees Celsius. Okay, so I use 100, 200, 300 on the T, on the temperature axis, and I use 50, 100, 150, 200 on the time axis. That doesn't mean that you cannot use 50, 100 on both axes. So anyone you like. Okay. Now said a calorimeter contains 5 grams of ice at minus 10 degrees Celsius. However, is heated uniformly until it boils. That means temperature will move from minus 10 to what? 100. So it will move from minus 10 to 0 first. You know, ice melts at 0 degrees Celsius. Okay, but it must be a pure ice. So because if the ice is not pure, they were supposed to tell us the melting point. Do you understand? The melting point. So they are assuming that the ice is pure. Are you there? The ice is pure. So the ice will melt at 0 degrees Celsius. It will melt at 0. So the temperature will go from minus 10 to 0 to melt. Then it will not go from 0 to 100. where it will boil. Are you there? But and at change of state, at the point where it is melting, the temperature remains constant. At the point where it is boiling, temperature remains constant. So let's go from minus 10 degrees Celsius to 0. So you come to this side. This thermometer is minus 100. So minus 10, just assume that is very close to 0. It's minus. I want to take minus 10 from here. Okay, minus 10. Let me use the red marker. So minus 10. So minus 10. Okay, to go like that, minus 10 to that. So I'm taking here as my minus 10. Minus 10. Okay. All right. So from this point to this point, you know, I put horizontal line here. This horizontal line is at 0 origin. Is at 0 origin. Are you there? Though time is increasing. Are you there? You know, time will be increasing. Are you there? But the temperature will remain horizontal, because that horizontal distance means that the melting point is the melting point at is 0 degrees Celsius. So they tally with the horizontal line, telling you that the temperature is what? Is 0 degrees Celsius. Are you there? So this horizontal line, you can extend it as long as you can increase the length, you can shorten the length, you can use any length you like. Time will be increasing, do you understand? But the temperature remains 0 degrees Celsius. So the ice melt at 0 degrees Celsius. So it moves from minus 10 to 0. So at the melting point, the line will be horizontal. So this is the melting point. Are you there? So you can do the horizontal line from 50 to 100. You can do the horizontal line from 50 to 150 if you like, before you move up. Okay. So now from this point now, it will now move towards 100. Now move to 100. But don't forget that we're told that it boils it starts boiling. It's going to say a calorimeter containing 5 grams of ice at minus 10 degrees Celsius is heated uniformly until it boils after 180 seconds. So our boiling state must be at 180. Are you there? So if I move from here now and I go up like this, and I go up to 100 degrees Celsius, good, it's boiling, but the time will not be at 180. But the time will not be, if I move this way now, if I go this way now, so the boiling point is at 100, are you there? But the timing is not 180 seconds. Are you there? So that means I need to extend this line. That means this line needs to be extended. Are we together? It needs to be extended to 180. So 180 is somewhere around here. 180 is somewhere around here. And that's what they are looking at for. Okay? So when we extend the melting, we extend this horizontal line to this, then we go this way. So extend to this, then move, then go. Okay, let me sketch. Well, it must be a kind of a curve. Okay, and this must be at 100. Line at 100 here. At point 100. Okay. So like that. Okay. You can see the points 180 here. That's 180. Okay, 180 seconds. So this side is the melting point. So this region here, from here to here, that's the melting point. Okay, that's from here to here is melting point. So why, it boils at 100 degrees Celsius, right? So look at this line, this horizontal line must correspond to 100. Okay, this horizontal line must correspond to 100. So that means from here to here is the boiling point. Okay, is the boiling point. Are we together? So they say we must label it. Do you understand? So from this point to this point is melting point. From here to here is boiling point. Are we together? So now at this level, from here, this curve from here to here is solid state. It's still in solid state. From here to here is solid state. Okay, you write it there, solid state. From this point, this curve here is a solid state. So you write it there. So solid, you write it where in your own book, solid state. Solid state. Okay. While this second curve from here to here is the liquid state. It has melted into water. So is the liquid state. So from this point, this second curve is the liquid state. So liquid state. Okay. All right. Okay. So this is it. So they are targeting your -10, your 0, and your 180. Then your 100 degrees Celsius. That's what they are targeting there. That's what I want to see. Okay. So and from this stage start vaporizing. After at 0 degrees Celsius, it's still what? Vaporize. Okay. It's still vaporize. All right. Still vaporize. Let's look at another question. So the 13B, let me just a calorimeter contains 5 grams of ice at -10 degrees Celsius is heated uniformly until it boils after 180 seconds. Sketch a label graph to illustrate the variation of temperature of ice with time. Okay, so the boiling point started from, can you see? Started from here at 100 degrees Celsius, and the time is what? At 180, it started boiling. All right, let's look at 13C. We are done with 13B. Let's look at 13C. 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 This says a 40 Celsius thermometer. A 40 Celsius thermometer reads 5 degrees Celsius at the melting point of pure ice, and 95 degrees Celsius at the boiling point of water at normal pressure. A 40 Celsius thermometer reads 5 degrees Celsius at the melting point of pure ice and 95 degrees Celsius at the boiling point of water at normal pressure. Calculate the correct temperature reading. When it reads 40 degrees Celsius. So we have different types of temperature scales. We have centigrade scale or Celsius scale, Fahrenheit scale, Kelvin scale, Rankine scale, and all that. So this one is a Celsius scale or centigrade scale. So you have one thermometer that is 40. This one is 40. A vertical line 40. That one is the 40 thermometer, a vertical line. So the lower part is the ice point, the upper part is the steam point or boiling point. So then I said a 40 Celsius thermometer reads 5 degrees Celsius at the melting point. The melting point is the ice point. Are you there? That's the bottom 5. This is 5 degrees Celsius. That's 5 degrees Celsius. Then 95 degrees Celsius at the boiling point of water. Boiling point is the upper part. 95 degrees C. Okay, that's 95. Okay, so let's now move to the one that is not 40. The one that is not 40. Okay, that is the one that is not 40. So you draw another vertical line. Okay. this one is not 40. That one is the second thermometer that is not 40. So for the one that is not 40, so the ice point, the melting point of the one that is not 40 is constant, is 0 degrees Celsius. Is 0 degrees Celsius. While the steam point or boiling point is constant, that's 100 degrees Celsius for the one that is not 40. You bring that one by yourself. So in that said, calculate the correct temperature. Calculate the correct temperature reading when it reads 40 degrees Celsius. That is when the 40 thermometer reads 40 degrees Celsius. Just 40 degrees Celsius should be somewhere around here. Just assume that this one is 40 degrees Celsius for the 40 thermometer, corresponding to what's the corresponding temperature here. Let's leave it theta for the one that is not 40. Okay, so what are you going to do now? You just do medium minus bottom over top minus bottom. Medium minus bottom over top minus bottom. Let's come to the 40 thermometer. Medium minus bottom over top minus bottom. So medium minus bottom, that's 40 minus 5. 40 minus 5 divided by top minus bottom. 95 minus 5. 95 minus 5. That's 95 minus 5. So all equals to 95 minus 5. 95 minus 5. Okay. So all equals to. So let's come to the one that is not 40, the correct thermometer. Theta, medium, same thing, medium minus bottom over top minus bottom. So medium, theta minus bottom, 0. Theta minus 0, that's theta minus 0 over theta minus 0 over top minus bottom. That's 100 minus 0, 100 minus 0. So let's solve that. 40 minus 5, that gives us 35 over 95 minus 5, it gives us 90. Okay, all equals to theta minus 0. Theta minus 0, that's theta all over 100 minus 0, that's 100. That's 100. So from there, make theta the subject of the formula of the relation that and cross multiply. That's theta equals to 35 times 100 all over 90. 35 times 100 all over 90. So with the calculator, what they have there, that's 3500. 35 times 100 divided by 90. 38.89 degrees Celsius. 38.89. 38.89. So theta equals to 38.89 degrees Celsius. So that's the correct temperature. 38.89 degrees C. 38.89. So that's the answer for that. So hope you are learning. All right, with this you can start marking yourself. Start marking yourself. That's 13C. Okay. Correct temperature reading when it reaches 40 degrees Celsius. That has been done. All right. So we have done with that. So let's move to another number. Okay. So in that side, the Roman figure 2 says, it said we have this one Roman figure 1. We have to find, we have done Roman figure 1, but Roman figure 2 says we should calculate the temperature at which it's reading. The temperature at which it's reading will be exactly the same as the correct temperature reading. That's Roman figure 2. See, the temperature at which it's reading, that is the reading of that 40 thermometer. The temperature at which the reading of that 40 thermometer will be exactly the same as the correct temperature reading. Okay, what I'm going to do there, that means we'll make the temperature at which is reading will be exactly the same as the correct temperature. Are you there? The correct temperature reading for when it was 40 degrees Celsius, the correct one was 38.89 degrees Celsius, right? 38.89 degrees Celsius. So this is the correct temperature. So if you put this here, if you put this theta here, at 38.89 degrees Celsius, we put it here. Then one will now put an unknown here. Are we together? So the temperature at which is reading will be exactly the same as the correct temperature reading. So that means if you now come, that remember we got 2. If you now put if you come here, you put 38.89 degrees Celsius here. Are you there? So what are you going to have? If you 38.89 degrees Celsius, you have 40 degrees Celsius here. Are you there? That means when the 40 thermometer is reading 40 degrees Celsius, the correct temperature is 38.89 degrees Celsius. When the 40 thermometer reads 40 degrees Celsius, the correct one is what? 38.89 degrees Celsius. Now the rough got now says the temperature at which is reading will be exactly the same as the correct temperature reading. That is, let the temperature at which their readings will be the same be any alphabet of your choice. Are you there? So let the temperature at which the reading will be exactly the same, let it be any alphabet of your choice. Let me use X. Are you there? That means if you have 50 here, you must have 50 here. If you have 40 here, you must have 40 here. If you have 20 here, you must have 20 here. If you have 70 here, you must have 70 here. And the value must be the same. So pick a particular alphabet of your choice and put it there. So let me use X. So if for correct temperature, if it is X, here must also be what? X. The same. Are we together? The same. X, X. So let's follow the same pattern. For the 40, medium minus bottom. Medium minus bottom. That's X minus 5. Just change this one to X. That is X minus 5 over top minus bottom. 95 minus 5. Now I see there 95 minus 5. So equals to the correct temperature, medium minus bottom, that is X minus 0. So X minus 0 all over 100 minus 0. That's 100 minus 0 is there already. So let's now solve. Okay. So we now have X minus 5, X minus 5 over 90. 95 minus 5 is 90, right? So equals to X minus 0. X minus 0 is X over 100 minus 0, 100. Okay. Can we now cross multiply and solve for X now? So cross multiply, that's 90 or 100 multiplied by S minus 5. That is this way. That's 100 bracket S minus 5 equals to 90 times S. That's 90x. So open bracket, 100 times S, that's 100x, minus 100 times 5, that's 500, all equals to 90x. All equals to 9. 100 minus S minus 500 equals to 90s. Okay, collect like times. 90s goes to that side. So that would be 100x minus 90x equals to 500. 500 goes to the other side, and the sign thing is to plus. Are we together? So 100s minus 90s will give us what? 10x. So 10s equals to 500. Together? Okay. 10s equals to 500. Okay, so making s the subject. So s equals to 500 divided by 10. So x equals to 50 degrees Celsius. So at 50 degrees Celsius, the temperature their temperatures will be what? The same. At 50 degrees Celsius, their temperature will be the same. That's for Roman, that's 13C, Roman figure 2. So let's go to number 14. Number 14. Oh, it's interesting. See water is life. I just drank water. Don't forget, click on the like and subscribe button to see video of chemistry, physics, technical drawing, maths that I have uploaded. Alright, when you click on subscribe button, you go to YouTube, then you see other videos I've uploaded. Okay, you log in with your mail and you click on that subscribe button, see other videos. Alright. Life is simple. Number 14A now. State Snell's law of refraction. State Snell's law of refraction. Snell's law of refraction states that the ratio of the sine of angle of incidence to the sine of angle of refraction for a given pair of media, are you there, is a constant. Snell's law of refraction states that the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. Media is the plural of medium. Like when you have air and glass. So if light ray is incident in the air and it is refracted in the glass, so at a particular angle, the angle of incidence, the sine of angle of incidence all over the sine of angle of diffraction is equals to a constant, and that constant is the refractive index of the glass. Refractive index is just mere, to a layman, is just the ability of the material of that glass to refract the light, to bend the light, to change the direction of light. Oh my goodness. All right, that's Snell's law of refraction. I've stated that. Now 14AI. 14AII. Why does a musical note? Why does a musical note? Why does a musical note of the same amplitude? Why does a musical note of the same amplitude and frequency? If you state that Snell's law, you can put your mathematical formula there to get a formula. Refractive index equals to sine I over sine R. Refractive index. Okay, so this symbol is just take it as refractive index. Okay, you can as well put a small letter n to represent the refractive index. Okay, equal to sine I over sine R, where I is the angle of incidence and R is the angle of refraction. So now back to Roman figure 2. Why does a musical note of the same amplitude and frequency being played on a flute, guitar, and trumpet sounds different? Why does a musical note of the same amplitude and frequency being played on a flute, guitar, and trumpet sounds different? They played a note on a flute. They played a note on a guitar. They play a note on a trumpet, and the notes played are of the same amplitude. That is same loudness. Are we there? So that same amplitude means about same loudness. Then and same frequency. That same frequency means same pitch. Pitch, P-I-T-C-H. Are you there? Same pitch. So the note that is coming from the flute, from the guitar, and the trumpet, they have the same. So they play the note of the same pitch and of the same loudness. And they found out that the sound that came out, the sound that came out from flute is different from that of guitar. The guitar is different from that of trumpet, and the trumpet is different from that of flute. That the sound that came out sounded differently, despite the fact that they are of the same loudness and the same pitch. So what's the difference? What's the reason? The reason is because the three instruments, flute, guitar, and trumpet, are of different qualities. They are of different qualities. Are you there? They are of different qualities. You now go further and explain. When I say the reason is because they are of different qualities. Full stop. Full stop. Then you now go further and write another sentence and say the note that comes out of any musical instrument depends on the harmonics or overtones. Is a blend of fundamental frequency and the harmonics, or a blend of fundamental frequencies and overtones. Any note that comes from a musical instrument is a blend of fundamental frequency and harmonics, or fundamental frequency and overtone. And don't forget that the harmonics are multiples of fundamental frequencies. Are you there? Fundamental frequency. Okay. So that's the reason. First sentence you write is because the three instruments are of different qualities. Then you go further and explain that the note that comes out of any musical instrument is a blend of its fundamental frequency and its overtones or harmonics. So that's the reason. Now 14bi. Mention one similarity between a camera and the human eye. Say mention one similarity between a camera and the human eye. You have a camera and you have human eye. Are you there? A camera and the human eye. So what is the similarity? One particular similarity. Now the eye has a convex lens. The eye has a convex lens. The camera also have a convex lens. So both of them have one convex lens or converging lens. Are you there? We are talking about one eye. Are you there? So both of them have one converging lens. We're talking one eye and one camera that has one lens. Are we together? So that is one similarity. Are you there? So another similarity is that the human eye is impregnated with a black pigment. The human eye is impregnated with a black pigment. There's a black pigment in our eye that you can see. The human eye is impregnated with a black pigment. Are you there? Now the camera inside, the inside of the camera is also painted black. So that's similarity. So the inside of the camera is painted black. That's two similarities. Now let me give you another one. The iris in the eye is the same, corresponds to the diaphragm in the camera. The iris in the eye corresponds to the diaphragm in the camera. Another similarity is this: the pupil is a small. The pupil corresponds to the aperture in the camera. Aperture in the camera is a small hole through which light enters. So the pupil in our eye is also a small hole through which light enters. Are you there? So the pupil in the eye corresponds to the aperture in the camera. Are you there? So why the iris in the eye corresponds to what? Diaphragm. So it controls the amount of light that enters. The iris controls the amount of light that enters the eye. The diaphragm controls the amount of light that enters the camera. So I've given you about 4 differences now. Okay, 4 similarities. Sorry, 4 similarities. So but you have to pick one. Okay, let's look at II. 14bi. 14bi says give one difference between a camera and the human eye. Give one difference between a camera and the human eye. Difference between a camera and the human eye. Number 1, the human eye is a biological organ. The human eye is a biological organ. The camera is a mechanical device. Is a mechanical device. The human eye is the biological organ. The camera is a mechanical device. Are you there? Now, another difference is this: the human eye can suffer a defect of vision. Some people are suffering from short-sightedness, some people are suffering from long-sightedness, some people are suffering from astigmatism, as in defect of the eye problems. Do you understand? Eye problems. Okay, so the human eye can suffer from a defect of vision, but camera cannot suffer from a defect of vision. Cannot suffer from a defect of vision. Are we together? I've given you two now. Now look at it. The distance between the lens and the retina of the human eye. The distance between the lens and the retina of the human eye is fixed. It cannot be changed. It cannot be varied. Either the distance between the lens and the retina of the human eye is fixed. It can be varied. Either. But in a camera, the distance between the lens and the film, either can be varied, can be adjusted. Either so as to get sharp image, sharp photograph of the object. Either can be varied. So another thing is this: I've given you three now. There are three differences. Three differences. So the focal length of the camera, cannot be varied. The focal length of the camera cannot be varied, but the focal length of the eye can be varied. The focal length of the eye can be varied. That's why your eyes can rotate left and right, can rotate. Are you there? So the focal length of the eye can be varied, but the focal length of the camera cannot be varied. If a camera has a focal length, if a camera is using a lens that has a focal length of, for example, that's the equivalent of 30 centimeter, that would be it. 30 centimeter. It cannot be increased, it cannot be decreased. If the focal length of a camera is, let's say, if the focal length of the lens the camera is using is 30 centimeter, it will be 30 centimeter. It cannot be reduced, it cannot be increased. Are you there? But for eye, that's what I said. The focal length of the lens of a camera cannot be varied, but the focal length of the eye can be varied, can be changed, and that is why eye has the power of accommodation. Accommodation is the ability of the eye to focus near and far objects due to variation in the focal length of the lens of the eye. Thank you so much. All right, that's my 14BII. So let's now go to 14C. 14C. Don't forget to click on the like and subscribe button. When you click on the subscribe button, you see more videos uploaded on the physics, chemistry, technical drawing, maths, and all that. Okay. 14C says a light ray traveled from water into the air. Okay, and don't forget that I've done parts. The theory part started from number 1. Are you there? 1 to 11 has been done. Are you there? 1 to 11 has been done, and I termed them part 1, part 2. Are you there? So when you click on the subscribe button, you see those videos. A light 14C now, a light ray traveled from water into the air at an angle of incidence of 30 degrees. A light ray traveled from water into the air at an angle of incidence of 30 degrees. Okay, calculate its speed in water. Remember figure 1, calculate its speed in water. Remember figure 2, the angle of refraction in the air. So we are given in bracket, they gave us the speed of light in air as 3.0 times 10 to the power 8 meter per second, comma, and the refractive index of water 1.33. They are giving all those parameters. So let's start solving. So the gun says a light ray traveled from water into the air So formula is the refractive index from water, small letter W, to what? Air. From water to air. They say a light ray travels from water into the air. So from water to air. So the left hand side is your water, the right hand side of the N subscript is air, A, small letter A. Are you there? So if you move from air to water, A will be here, W will be here. Are you there? If it moves from air to water, A will be here, W will be here. Are you there? But when it moves from water to air, W will be here, A will be here. So the first one will be at this left hand side, while the second medium will be at the right hand side. Both of them are subscripts. Are you there? So once you have that, so it now equals to, let me show the speed of the light in water. So I'm using V to represent speed, subscript W. Are you there? The speed of the light in water, V subscript W, all over V subscript A, and the speed of the light in air. Are you there? So the left hand side will always be at the numerator, while the right hand side will always be at the denominator. Are you there? So light travel from water to air. So water will come here, air will be here as subscript. So this goes with numerator, this goes with the denominator. That's the logic behind it. Okay. So now speed of light in water, that's V subscript W, all over speed of light in air, that's V subscript what? A. You can also write it in full, in words, speed of light in water over speed of light in air. So now they say a light ray travels from water into the air at an angle of incidence of 30 degrees. We are still coming to that angle of incidence. Are you there? Calculate, I remember figure 1, its speed in water. Its speed in water. Are you there? So the speed in water is given as, we are looking for the speed in water. We are looking for V subscript W. So that means we must have a value for speed in air. Speed in air is given in the question as a constant. The speed of light in air is 3.0 times 10 to the 8 meter per second. So VA is given. Now what's the refractive index? They said the refractive index of water is 1.33. Are you there? C. Refractive index of water is 1.33, right? This refractive index from water to air. Are you there? So you invert it. That is, look at the refractive index. That is, this is same thing as 1 over refractive index from air to water. If you are given, if it says refractive index of water is 1.33, it means air to water. Air to water. If you see this sentence that says the refractive index of water is 1.33, it means air to water. It means when light rays travel from air to water. If I say the refractive index of glass is 1.5, it means that light travels from air to glass. That one is constant. Are you there? So, but now what we are having here is water to air, and the question says the refractive index of water is 1.33, and don't forget that the refractive index of water from 1.33 means that light travels from air to water. So we have to invert it. That means this is the inverse of this. So you have to turn this on to 1 over air to come back to air to water. It's constant. The refractive index of glass is 1.5. It means light travels from air to glass. That is A to G. The refractive index of water is 1.33. It means that refractive index air to water is 1.33. Is that okay? So equals to V subscript W over our speed of light in air is 3.0 times or 3 times 10 raised to the 8. Okay, like that. So 1 over 1.33. So air to water is 1.33. If you substitute ordinary 1.33 here, you get the wrong answer. If the index of water is 1.33, it means air to glass. So you now find the reciprocal to get air to water. Don't forget that's what's behind it. So 1 over 1.33 equals to V subscript W, velocity of water all over 3 times 10 raised to the 8. 8. So 3 times 10 to the power 8 is now 3.0 times 10 to the power 8. So let's cross multiply and make our speed of water. Sorry, the formula. Multiply like this. So we have the speed of water equals to 3 times 10 raised to the power 8 over 1.33. So 3 times 10 raised to the power 8 over 1.33. 3 times 10 raised to the power 8. Okay, you can divide that with the calculator. Divide that, what we get, that's 3 divided by 1.33. Now I won't end here. 2.26. That is speed of water equals to 2.26 times 10 raised to the power 8 meters per second. That's speed of light in water. 2.26. So can you see? Can you see that we said light is fastest in air. The speed of light in air is the highest. So the speed of light in any other medium is it will be lower than 3 times 10 raised to the power 8 meters per second. Can you see that the speed of water now, the speed of light in water is now 2.26 times 10 raised to the power 8 lower than 3 times 10 raised to the power 8, which is in the air. So that's my figure 1. Said a light ray travels from water into the air at an angle of incidence of 30 degrees. Calculate its speed in water. My figure 1. Now I've got to say the angle of refraction in the air. That is when we are going to use our eye. The angle of refraction in the air. Don't forget that our refractive index, same from water to air, equals to sine of angle of incidence in water over sine of angle of refraction in air. We are still maintaining from water because light rays move from the water to air either. So incident is in the air, refraction is incident is in the water. The light rays move from water to air. So incident ray is in the water, refracted ray is in the air. That means the angle of incidence is in the water, the angle of refraction is in the air. So sine I over sine R. So this, if I divide this from water to air, you also change it to 1 over. It will also be 1 over refractive index air to water. So all equals to sine I over sine R. Sine I over sine R. Sine I over sine R. Okay. So coming out to the truth. So that's 1 over 1.33 equals to sine 30 degrees. Our angle of incidence is given as 30 degrees, sine 30 degrees. So all over sine of refraction. Okay. So let's now make our sine. Sine I is 30 degrees. It's the angle of incidence is 30 degrees. That's when we now use that particular angle. So let's multiply and make sine R the subject. So before that, let's say 1 over 1.33 equals to sine 30 is 0.5 over sine R. Okay, 0.5, 1 over 1.33 equals to 0.5 over sine R. Making sine R the subject, we can multiply. So sine R equals to 1.33 times 0.5. 1.33 times 0.5, that's 0.665. 1.33 times 0.5, 0.665. 0.665. So 0.665. So I'll make R the subject, small letter R, which is the angle of refraction we're looking for. So that means small r equals to sine inverse or arc sine 0.665, and that is giving us what? Arc sine 0.665. Shift here, shift sine 0.665, and that gives us 41.68 degrees. 41.68 degrees. Approx 42 degrees. That's the angle of refraction in the water. That's the angle of refraction in the water. That's the angle of refraction in the water. Are we together? So we have done number 12, number 13, and number 14. So we are left number 15, 16, and 17. Okay, number 15, 16, and what? 17. So we'll do number 15, 16, and 17. So in another video. Okay, so in another video. So thank you so much for listening. Number 15, 16, 17. You have 15, 16, 17 remaining. We do it in another video right there. So click on that subscribe button or like, and then you get other videos. Okay, all right. For maths, chemistry, technical drawing, and physics, you see them there. Thank you so much for listening. So this is Campus Academy. Bye for now.